In the last video, we saw how the two pointer operators work. That is the ampersand operator, which you can think of as the address of operator, and the star or the dereferencing operator, also referred to as the value at operator. And let's take a look at some programs that use these operators. Okay. So here's a simple program. All it does is declare a variable I, set it equal to 0, declare a pointer variable j, pointer to int, and have it point to I. So that uses the ampersand operator. And then we try to print out I and j, and you can use few formatting strings, but the %p is one that works pretty well. This will print out a pointer in hexadecimal notation, so you will see numbers with the letters A through F, usually in lowercase. And then here is our dereferencing operator, star j. What this says is print the thing that is pointed to by j, or you can say print the result of dereferencing j, or you can say the value at the location pointed to by j. Okay, so let's quickly compile this. GCC and run this, and the output is pretty straightforward, just 2 lines. Prints out I is 0, sure, we set I to 0 and therefore it should be 0, and then prints out j. J is this big long number. It just so happens I'm working on a 64-bit Mac OS X computer, and so that's why this address is so huge. And then finally we print out what j points to. We say j points to, and then we print out star j, which is dereferencing j, and so it prints out whatever j is pointing to. So in this case, j is pointing to I, which has the value 0. You can do the same kind of thing with double precision numbers. So you can declare a double x equals 3.14, and then have a variable p that points to x, print out x, and use %f. And if you've used Java system.out.printf, you know how this works. You probably used %f. And then you can print out p as well using %p, which doesn't exist in Java. And then we say p points to, and we can use the dereferencing operator. Okay, so all of this works. So let's make some minor changes. So vi 17.c. What I'm going to do is I'm going to assign a value to star j is equal to 25. So once again, note that we initialize I to 0, and then we don't really do anything directly with I except have j point to I. And if you've been following the lectures, you know that once you do this, star j is equal to 25, and you print I, even though we don't have I on the left-hand side of an assignment operator, we know that I will be changed. Okay, so by the time you get around to printing this, it'll say I is 25. And so what we can do is maybe print this twice. And do a YY to copy and P to paste. So I just copied and pasted a line. So I'm going to print the same kind of thing, print out I, j, and star j. You can do the same kind of thing over here. After I set x and p, I can say over here, I can say star p, that is the thing that p points to, set that equal to 1e to the 23, whatever that is. Okay, oops, need a semicolon. Hope that compiles. Alright, it does, and I'm going to run it. 17, and what I get is, oops, I forgot to print out x after I changed it. Alright, so let me cat out the program, and we look at the first two lines of output. So we set I to 0, we set j to point to I, and then we print out I is 0, sure. J is this big long number, which is a pointer or memory address, and then we say j, we see that j points to 0. Next, so between this print and this print, we do not change I directly. What we do change is whatever j points to. And notice here that when you say star j is equal to 25, it does not change the value of j. So j is still a pointer. It's pointing to the same memory location it used to before. What has changed is I. So it's, at first glance, it's surprising because between this statement and this printf, between these two printfs, we do not actually access I directly. What we do is we change whatever j is pointing to, just so it turns out j is pointing to I, and therefore by changing what j points to, or changing the value that j points to, assigning that location 25, we're changing I, changing the value of I. So very important thing to understand. Okay, so here we print out I equals 0 because that's what it was initialized to, and over here, just by changing what j, the value that j points to, I is also changed. It becomes 25, and then j remains the same, does not change, and we get the very last thing saying j points to 25. Okay, so we forgot to print x and p after this. Let's change that. So what we want to do is do the same kind of thing, roughly the same thing. We have an x value, x variable set to 3.14, have p point to x, and then we change star p, that is the thing that p points to. Okay, this is a very important thing, that's why I'm spending quite a bit of time on this. And then between these two printfs, we don't actually change x, but you know, and you can follow the same logic as up here, that what we will see, if everything works, is that it'll say x is some big number. Alright, let's compile this and run it. Okay, so this, oops, it doesn't show up here. Let's just cat it, just to make sure that it is actually there. It should be there. Okay, so we print out x is 3.14, sure enough, there it is, 3.14. P is this other big pointer variable or pointer value. And say it says p points to 3.14, that's all fine. And then after that print and before the last print, we do not actually directly access x. All we do is change star p. So we say whatever p points to, we set that equal to this big huge number, and sure enough we get that big huge number, well, something close to it. So this is roughly, I believe, 10 to the power 23. Okay, and then p remains the same, that's important. P does not change. You can actually change p, you can add one to it and so on. And you'll see what happens when we do that. And we also, just like before, we see that P points to that big number 10 to the power 23. Okay, so let's do one more thing. Okay, so this time what I'm going to do is, rather than changing what j points to, I'm going to say j is equal to j plus 1. Okay. And I'm going to change this to p plus 1. And then I'm going to print it out. Okay, so this time around what we're doing is we're not changing what p points to, we're changing p itself. Okay, so let's see what we get. Compile it, and it turns out there's no errors. That's one of the things that's surprising, because what we're really doing is, cat out this program, like x17.c, we're changing the value that j has. So j was pointing to I. If you bump it up by 1, it'll be pointing to some other thing. So let's compile that to make sure it works, and then run it. And notice that I does not change, x does not change. What j points to, it turns out, doesn't change, but that's probably just fluke. That's just luck. Over here, notice that what p points to does change. The big difference is the value in j. And notice the difference between these two values. J is initially this big long number ending with a 4, and then once you bump it up by 1, the new number goes up by 4. And so that's a surprise. At the same time, look at what happens with P. P was initially this value ending in a 0, and then once you bump it up by 1, you get a new value that ends in exactly the same thing, except the very last digit is an 8. And you can do the hexadecimal math. These two addresses differ by a value of 4, and these two addresses differ by a value of 8. So this is called pointer arithmetic. So what we're doing is we're doing arithmetic with pointers, just adding 1 to it in this case. So it turns out that C keeps track of what kind of pointers we use. In this case, since we're using pointers to integers, and integers are just 4 bytes, if you try to bump up the value of a pointer, you bump it up by 4. And that's completely because J is a pointer to an int. P is a pointer to a double, which is and each double is 8 bytes. So if you're pointing to one double and you want to point to the next thing, and the way you do that is just to add 1 to it. And when you do that, what you end up doing is pointing to something 8 bytes away. That is the next double. So that's one thing that you want to keep in mind at first glance. It doesn't make sense. You're just adding 1 to it, but it's going up by 8 here. And you add 1 to J, and it's going up by 4. That's because of the type of thing that it points to.